physical states of matter like solids, liquids and gas in chemistry. And in mechanics, a body has only two states. One is state of rest and another one is state of motion. Then, what do you mean by state of rest? Suppose, if the position of an object does not changing with time or surroundings, the body is said to be at rest. Then, state of motion. Suppose, a body's position or location changing with respect to time or its surroundings, then we can say the body is in motion. The another two familiar terms you have are distance and displacement. From our small classes, we are learning about these topics, distance and displacement. First, have a look at what is this difference between this distance and displacement. What is distance? Suppose a particle is moving or a body is moving from point A to C through the point B. Suppose the distance between A and B is 3 meters and distance between B and C is 4 meters. Then, what is the distance? Here, the definition of distance says that it is a total path length covered by an object. Here, the object moving from A to B, then from B to C. So, the total path length is AB plus BC, that is equal to 4 meters plus 3 meters. So, our distance traveled is 7 meters. And this quantity is a scalar quantity. It has no direction, only magnitude is significant here. Its SI unit is meter and its dimension is L. Whereas this displacement, so we can take the same case, we are starting from A to B, then reaching the point C. Now, the definition of displacement tells that it is the shortest distance between the initial and final position. Here, we have the initial position is point A and our final position is C. So, then the shortest distance, we know, the shortest distance between any 2 points is a straight line distance. So, the shortest distance is a straight line connecting the points A and C. And since this displacement is a vector quantity, we have to define its direction also. So, the correct definition of this displacement is, it is the shortest distance between initial and final position in a fixed direction. Because it's a vector quantity, its direction has equal importance as its magnitude. In this case, suppose the distance are 3 meters and 4 meters. Then our displacement is, from Pythagoras theorem, it is root of 3 square plus 4 square. The answer is 5 meters. Since this displacement is a vector quantity, it has both magnitude and direction. Suppose a body is moving from A to B. Initially moving from A to B, suppose the distance or the path length between them is 4 meters. Then the displacement when it travels from A to B is taken as plus 4 meters. Is plus 4 meters. Then what will happen if he returns from B to A? On his return, he travels the same distance 4 meters, but the direction is changed. So we can represent the displacement when he travels from B to A is minus 4 meters. This minus does not tell us that this value is less than 0. This minus signifies its direction only. Suppose that the body returns to its initial position. He completes a round trip. Then we can say from A to B, then from B to A, the total displacement is 0. So we can conclude that this displacement can possess both positive and negative as well as 0 value. Whereas this distance can only have this positive value because the length of the path never decreases. Now we have a clear idea about